All right, so let's do one other thing in relation to completion of square. That is very important. It's about expressing quadratic equation in their vertex form. Now, who can give me, Laurie, who can give me a quadratic equation in a standard form? What would it be? Yes. In a standard form. Amanda. A quadratic equation in a standard form. How is a form like A in that kind of order? Standard form or general form? What? Ax squared plus bx plus c, standard form or general form. However, if you express something in this form, it can be, you don't get a lot of information, right? So you have to express in the form that you can get enough information about the graph without having to plot it. Is that okay? So that's what brings about the vertex form. Just as the name suggests, you can get the vertex. What's the vertex of a graph? There's also another, it starts with a T. Is the what? Hey, start with a T. No. Turning point. The point at which the graph is turning. If I have a graph like this, a parabola like this, the vertex is going to be the turning point. Right? Okay, so we have to learn how to express our standard forms into vertex form because we want to have some other information that this guy can't readily give us. Is that okay? So let's see. It's always written in the form A into brackets x plus h all squared plus k. A into bracket x plus h all squared plus h plus k. These things here are arbitrary. Some people may put d here, some people may put any other value at all. So when I'm able to express this into this form, then it means that my h value gives me the point at which, pay attention here, gives me the point at which the value is occurring, and then the k is a y value. For example, I know what I said, many people didn't get it. If I should have a graph like this, this is a parabola. So this h value tells me the point on x at which is occurring. Do you get that? And then this k tells me that, okay, it's at y equals to a certain number. So the turning point, let's say if this is, let's say 3, this is around minus 4. It simply tells me that the graph has a vectors of 3 and then minus 4. This way it's turning. Do we get that? Can I move on? All right, so let's see how we can push this guy to now start looking like this. Let's use a question to explain that. For example, if you are given something like 3x squared minus x minus 6 equal to 0, or just that, not equal to 0, it's just an expression like this, and you are told to put this into a vertex form, the first thing to know is that if you are completing the square, what's the feature about the x squared term? It must be what? It must have a coefficient of 1. Remember when we are proving the quadratic formula, this should have a coefficient of just 1. I'll have 3 outside, bracket x squared, watch here, minus x over 3, minus 6 all over 3. I can simplify something here, right? This will be minus 2. Okay. Now, if I'm complete, so at least I've put the 3 outside here so that I can just see these guys and complete the square here. When I'm done, I'll now relate it with the 3. So that's the first thing to do. So I have 3 into brackets, x squared minus x over 3 What is half? If I have to complete the square on this side, I would have to add half the square of 1 over 3. 1 over 6, sure. That's good. 1 over 6 minus 1 over 6 all squared. Then this will now be, I'll now subtract minus 1 over 6 all squared. So I'll add to one side, subtract from another side. So that I can just keep the same thing. I hope you get that. In math, you're allowed to manipulate things without changing their values. If you can do that, you are good to go. So here I would have 3. And then this becomes what? X, help me. Minus 1 over 6. Minus. This whole thing becomes what? Some kind of big value. Just feed this in the calculator and let me know. Remember the square here will affect this guy. It will become 73. So minus 73 on 36. Who else also got minus 73 on 36? You all got that? Okay. So finally, I'll now have an impact, or I'll now relate it with the 3 over here. So we'll have something like 3 multiplying this bracket, 3 multiplying this one as well. So I'll finally have 3 into bracket x minus 1 over 6 all squared. 3 relating with this part leaves it as what? 73 over. So minus 73 all over 12. So this is how I've expressed this whole thing into the vertex form. Now, so if another way this can be asked is that I can now tell the minimum or maximum value and the point at which they occur. Now the first question is this: the graph here, is it a minimum or maximum graph? Would it be a minimum or maximum graph? Minimum, because it's positive. Good. So we are finding the minimum of this guy. So I'll therefore say that the minimum value which is, like I said, is this k term. The minimum value is, I think you should plot this on the graph. Try, there's a graph up here. Just go there, this one, and just put it in 3x squared minus x minus 6. Let's, yeah, and the function here, new, here, insert function. So the minimum value is minus 73 over 12, and it occurs at the point, at what point? 1 over 6, because we said the minimum value will be found, it must be x plus age is equal to 0. Is that okay? The minimum, the point at which the minimum or maximum value occurs is at the point where x plus age is equal to 0. So in our graph here, we have x minus 1 over 6. So x minus 1 over 6 equal to 0. So what will be the value of x? It will be, 1 over 6. So x will be equal to 1 over 6. So I'll write, therefore, the exponent. I think you have to use this sign like this. Yeah. So the minimum value is, minus 73 over 12. And it occurs when x is equal to 1 over 6. Beautiful. Is that okay? So let's try for this second one. You should solve that. Find the maximum value of f of x and the point at which it occurs of the function 5 minus x minus 2x squared. Have you plotted it? All right, so let's watch this graph first. So the graph, like we said, 3x squared minus x minus 6. That would be that the minimum value is, first of all, it's a minimum graph. What is minus 73 over 12? As a decimal, give it to me in decimal. So you're around 6 points. Sorry. Negative 6 points. All right, so you can see that negative 6. So the turning point is around here. So negative 6 points what? 0. Yeah, you can see it from this side. Then the point at which it occurs is when x is equal to 1 over 6. What's 1 over 6 as a decimal? Should be around? Yeah, you can see that. So if we should match this thing around this side, if you zoom it a little, you notice that it will be 0.166, something like that. I hope you get that. All right, so let's do the second example too. Yeah. 5 minus x minus 2x squared. Let's put this in a let's do it together now. So you have to rearrange it first. So minus 2x squared minus x plus 5. All right, let's do it together, everybody. So pause. So minus 2x squared minus x plus 5. I can take out the minus 2. I'll have x squared minus x over 2. No, or plus x. Yeah, and this will be over 2. Is that okay? All right, so I'll have minus 2 into brackets x squared plus x over 2. What's half of 1 over 2? 1 over 4 all squared minus 5 over 2. 5 over 2 minus 1 over 4. 1 over 4 all squared. I get close. All right, so I'll now have minus 2x plus, x plus what? What do I add to this place? 1 over 4 all squared. And then this whole side becomes what? What's the value? Just punch that in the calculator and give it to me. Becomes what? What did you get for this side? The minus 5 over 2. 5 over 2 minus 1 over 16. This whole thing here. I'm hearing two different answers, so it will be minus 41 over 16, right? Who else also got for minus 41 over 16? You also got that? Okay, so let's multiply through. That will now be minus 2 multiplying x plus 1 over 4 all squared, and then minus 41 all over 8. So what are the vertices? So let's go. The minimum, would it be a minimum or maximum graph? So let's plot it again. It will be a maximum graph. Why? It's negative. Yeah. So the maximum value is minus 41 over 8, and it occurs when x is equal to what? X is equal to, okay, when occurs when x is equal to minus 1 over 4. You negate the value here. Is that okay? So let's check it out on the graph and see something. Now, if you are plotting a graph, there are some interesting things you have to know about these values. If I have a value of, what's the minus 41 over 8? Give it to me in decimals. It will be minus 5 points. Okay, and this is minus 1 over 4, minus 0.25. 25. Okay, so as we can see, the minimum points is going to be maximum points. How come I got minus this one here? I think, oh, the minus 2 have an effect to give us plus. So it'll be plus 5.125. Okay, so let's go here. So plus 5, you can see that. Is that okay? Then you can also see that this is the x value is around what? The point at which it occurs, 0 point, so between somewhere here, minus 0.25.